Clark, can you so wait, whose question first? Uzair. Let's do Uzair's question. Okay. So I know you asked for help for the last two, but I'm going to do the whole one, just just for the sake of it. Okay, it won't be too long. Okay.
That's fine.
But I'm going to ask you to take me through what you did. Okay.
Okay.
Because so when you read this question, what did you think?
It looked straightforward, but when I got to 4.5, I just got a bit confused there.
But like starting off, what did you look at? So when you read the question, like what can you tell me about the question?
We have a parabola, and it's a
Yeah.
frowning parabola.
Yeah.
And we have a straight
Great.
line graph.
Great. So it's a straight line graph and a frowning parabola. Okay, so let's just highlight it, makes it look nice. Frowning parabola. Okay. And then what else?
We have the y-intercept.
What's the y-intercept?
3.
And how do you know that?
We see it in the formula.
You have the equation.
Yeah, the equation.
Yeah. So that's why, guys. So, okay, just when your mic is a bit loud, or if you're just able to mute it. Okay, it's yeah. So Uzair, are you there?
Yeah, man.
Yeah. Okay. So you were saying so you've got the equation, right?
Yeah.
The equation is really powerful. Why is the equation powerful? Because it tells you certain things about the graph.
Yeah.
So you read the equation. So you already knew, if I gave you this equation, you would already know it's a frowning parabola, right? Because A is negative, even if I didn't give you the graph. Okay. So that's the first question. The y-intercept is just 3. The coordinates of C, what did you do for that?
I did the long way, but I found out the A coordinate because I forgot the way you could use that B is equal to 2 something. I forgot that way, and then I just found the A
Minus
coordinate.
B over 2.
There we go. I got the middle of from the 2 x-intercepts, and then I put that x into the formula and got the y value, and then
That is an approach. There is a faster way, which you can find the derivative and put it equal to 0. Do you agree? Because so for those of you who haven't done calculus, have you done calculus yet, Cheswin? Cheswin, have you done calculus yet?
Yes.
Okay. So okay. So find the derivative, put it equal to 0. So do you agree that's a bit faster, Uzair?
Yeah, much faster.
Minus 2x minus 2 equals 0. So therefore 2x equals minus 2. Therefore x equals minus 1. And then you sub that into the main formula to give you the y coordinates.
Yes.
And that will give you
4.
Minus 1, 4. Okay. Then the third question, the coordinates of A. So you would have worked out A already, right?
Yeah.
But it's just the x-intercept, so you make y 0. Okay, and what did you get? Negative 3 and 1.
Negative 3 and 0.
Yeah. Not 0. Can be because
I thought x coordinate on A. The coordinate on A is 3 and 0.
Yeah. So I see what you mean. Yeah. Okay. So you just put y 0 and you solve the quadratic equation, which you guys, I'm sure, by now have done so many of those. Okay. The length of CE, what did you do?
Well, I have the coordinates of A and the coordinate of C, and then I found the gradient.
Yeah. Okay.
Of a straight line, and then I worked out the formula of the straight line by subbing A into that equation I got.
Great,
And then I put
great.
the
And what
straight
what
line
did you get?
equals
What did you get for the equation of the straight line?
y is equal to 2x plus c, plus 6.
2x plus 6.
Yeah.
Great. Okay, I think I see it now. Okay. Yeah.
And then since we have the coordinate, I just use the distance formula.
Yes.
Um,
So yeah, that's great. So you have this 0, 6, and you have this point here, and then you use distance formula. So what did you get?
2,24 units.
2,24 units. Okay, so
Yeah.
just for those, just to make it, distance formula, I'm sure you guys all know it, is this one over here. So you just take the two x values, you subtract them, the two y values, you subtract them, and you square each, and you take the square root. It's I like to think of it like that. The x value subtracted, squared, plus the y value subtracted, squared, all square rooted. Okay. Now we go to the big question. Okay. Okay, taking it up a level, up a gear. Yeah. Do you guys watch Top Gear? Why, guys? Just asking you. Okay. So, okay. It says here. Can you guys see it clearly? Maybe I should just quickly. Can you guys read it clearly?
Yeah. Yeah.
Determine. It's gonna take long. Okay, but it says determine the value of k if 2x plus k is a tangent to the graph. Tell me, what are the things that you guys know about tangents to the graph?
The derivatives are equal at the point of contact.
Yes. Yeah. Well, yeah. So the gradient of what's that famous saying? The gradient of the graph is the same as the gradient of the tangent at the point of contact. Remember, see, guys, when you wake up in the morning, that's what I want you to say. I mean, the gradient of the graph is the same. That and all these other calculus stuff. Okay, so it must become automatic. So like in like when you guys, let me just ask you something. When you guys walk, do you guys think about walking? All of you, I want you to just respond to this. Like,
No.
when you
No.
do you think about walking?
No.
Like, do you think like I'm putting my foot here and I put my foot there? Unless you have
No.
like a neurological illness, but when you walk, it's automatic, right? And that's because it's in a particular part of your brain called the basal ganglia, which just automatically does it for you. It just corrects your movement, so you don't have to think about it. Imagine you have to think about it every time you walked, right? Like how bad would that be? Like you have to think about every time you wanted to walk. So what I'm trying to make is, if you can get it to that point where you don't even have to think about it, the equations anymore, they're just that automatic. Do you guys see what I'm saying? Do you guys see what I'm saying?
Yeah.
Where you get to the point where it's so strong, you do it so frequently that it's automatic in your brain. You don't have to think about it anymore. So that's where I want us all to be, because then it becomes faster. Okay. So, okay, why did I say that? Okay, but anyway. Yeah. So it says a tangent. You said gradient of the graph, same the gradient of the tangent. So do you agree that this graph, let's just write it out there, h of x, what do you understand by this function, Uzain? H of x equals 2x plus k. What do you read when you see that statement?
It's a straight line graph.
Yes. What else about the graph?
The gradient is 2.
The gradient is 2, right? And what is k there? What is k?
The y-intercept.
Yeah, but so if I change k, what will that do to the graph?
The graph, up or down.
Yeah.
It's a vertical shift, right? So do you notice how I'm drawing the graphs parallel to each other?
Yeah.
Why? What did you say?
Gradient is equal.
So do you guys see that? Okay, see? So it's almost like if I make k 5, it's this, right? There. If k is naught, there's the graph. Do you see it? If k is -1, it's there. So you guys get the picture, right? Okay. If k is 6, it's there. Because that graph is 2x plus 6. Do you see, Uzain?
Yeah.
Okay. But now they're asking what is the grade, what is the equation of the they're saying it's a tangent. So what does that mean? Naima, what did you say about the tangent in the graph?
The gradients are equal at the point of contact.
So the gradient of the graph is what at the point of contact? If they give you the tangent.
2.
It's going to be 2, right? Because isn't the gradient of the tangent 2? Hussein, do you see that?
Yeah. I see.
So therefore the gradient of the graph is 2 at that point. Okay. So so maybe let's say it's over here, right? It kind of looks like it's there, right? Do you guys agree? It kind of looks like it's there.
Yeah.
Maybe it's equal to 7. I don't know. Let's work it out. So we know the gradient of the graph is equal to 2. We know that, right? The gradient of the graph is equal to 2. But what is the gradient of the graph? How can I find the gradient of the graph, an expression for it?
The derivative.
Do you guys see it now? The derivative is
Yes.
just minus 2x minus 2, right? That's the derivative. But I'm saying it's equal to 2. This derivative is equal to 2. And when I say it's equal to 2 and I solve for x, that's going to tell me the x value where my gradient is 2.
Okay.
Does it make sense? Okay. So the thing is, guys, you must just stop me. Nafisa, does it make sense?
Explain it again, please.
Okay, so you guys can just stop me. If anything doesn't make sense, I'm happy to repeat it because I want you guys to understand. So do you guys agree that the gradient of the graph is 2 because the gradient of the tangent is 2? Do you guys
Can you
agree
please
with-
repeat it again?
Okay, yeah. So the gradient of the tangent is 2. Here's the tangent. Well, we don't, yeah. And Naima told us that the gradient of the tangent is the same as the gradient of the graph at the point of contact. Because remember, the question says determine the value of k such that this graph is a tangent. So if it's going to be a tangent, then their gradients must be the same. Okay? Their gradients must be the same. Guys, that makes sense?
Yes, it does.
Okay. So that means that if the gradient of the tangent is 2, that means that the gradient of the graph at this point must also be 2. But what's the gradient of the graph, Elias? Minus 2x minus 2, because the graph is minus x squared minus 2x. Do you guys see that, officer?
Yes.
Okay. So let's solve for x. Minus 2x equals
4.
4. X equals minus 2. That kind of makes sense, right? So we said it's kind of like over here. So that looks like it's minus 2. It's kind of like in between, right? And they want the what? The value of k. So that's not the value of k, right? So how would we work out the value of k?
We can substitute -2 into the original equation.
Yeah. Yeah, because we, well, yeah, I mean, we just know the point that the graph goes to. So we know the point is -2. and you can work it out if you sub it into the into the equation. So
Yes.
what's the corresponding y value when you sub it into the parabola?
3.
Is it 3? Okay, so it's 3. So therefore, and you can work out the equation of the graph now.
Yes.
So because you have a point and you have a gradient, because the gradient is 2. So you can use that formula y minus y1. You guys know this formula? So it's y minus 3 equals 2x plus 2, because it's minus minus 2. Y equals 2x plus 7. Okay, we were right. Okay.
Sir,
Yeah.
can we
Don't call me sir. Don't call
also
me sir.
use-
Yes.
Okay,
What is
sorry.
your, what is your, I didn't get your name. I didn't get your name.
I don't know how to pronounce it. Ntabi.
Okay, it says Galaxy A7. So can you just tell me your name? I don't know who I'm speaking to.
Ntabi.
Oh, okay,
Singh.
okay. Did you? Oh, you're Tavi Singh. Okay. So yeah, okay. Nice to finally meet you. Okay.
Okay, so can you also pronounce your name to me so that I can just call you by your name, not by
you
Sir
can just, Ilias. You can just say Ilias. Yeah.
or Elias. Okay.
Yeah.
Okay, sorry.
So did you have a question, Tavi Singh?
Yes, instead of using the y minus y1, can we use the y equals to mx plus c?
Yes,
There's
different ways of doing it. I find this one a bit faster for me. So, you guys, if you have like a house, there's different ways of getting to the house. But as long as you find a way that works, like for example,
Okay.
Jose, at the start of this question, he still found the answer. It just, his way was a bit longer, but he still found the answer. Okay, so I think when you start practicing and you're doing lots and lots of examples, you start to see which methods work faster. You guys see that? So in which situations, and that just comes from practice. You can see which questions and which approaches to use in specific question, and it just comes from practice. Okay, so question 6. Determine the equation of the inverse. Have you guys all done inverse functions?
Nope.
Oh, you haven't done inverse. Okay, that's what. Uzair, have you not done inverse functions in class? Uzair?
Oh, Mafa. Well, to be honest, I don't really know the maths names of things, so
No, we
I
didn't.
don't know.
We
Okay,
haven't.
Oh,
done
okay.
this.
Oh, okay. So maybe that's why you didn't know. Okay, so the inverse, okay, there's a concept video on it that I want you guys to watch. If you guys, when you have a moment, let's just show you guys over here. If you look under functions, do you see here grade 12? Definition of a function, inverse of a function. You guys see that? Inverse of a straight line, parabola. So these videos will help you with this question. So determine the equation. Now, all you have to do is, if they give me the equation y equals minus x squared, right? Minus x squared minus 2x plus 3. Now, all you have to do to find the inverse is you swap x and y. It's not a nice color. You swap x and y. Okay.
So is that the 2 marks?
Well, they want you to make y the subject of the formula. You see?
Yes, I'm not sure if you see, but they're asking for the inverse of G, the straight line.
Oh, sorry. Thank you for that. Thank you. You've just made the life a lot easier because it's an easier function. Okay. So what's the equation of G again? It's y equals 2x plus 6.
Yes.
Okay. So do the same thing. What's it going to be?
X is equal to 2y plus 6.
Yeah. And then solve for y. Okay.
Mm.
So what's
So
that
take
going to
6
be?
over.
2y equals x minus 6. Yeah.
And then
And
divide
then
by 2
y equals a half x.
minus 3.
Mm. And if you go through the concept video, I will tell you that to work out if you want to work out the axis, if you want to work out where the inverse graph is, all you do is you draw the line y equals x. You draw the line y equals x, and all you do is you flex it about that line. So yeah. So now you have to see that. Okay, now yeah. So this is going to be like that. They probably do have to intersect at some point. I wonder if they intersect over here. Maybe they intersect over there. Because half x is very small, right? Right, guys? You guys agree it's a very small gradient. Something like that. Okay, anybody have a question? Okay. So y equals a half x plus minus 3 is the equation of the inverse. Okay, now they say determine the values of x for which the graph of G is greater than the graph of the inverse. Now, all these types of questions, there's a concept video that will put you out of your misery. It's in grade 10, finding the values of x that satisfy a particular statement. Okay, this video will, if you haven't watched it, change your life because it just helps you with all those difficult questions. What values of x, all this, because it looks very horrible, but it's not that horrible. Okay, so they basically are. So Naima, do you want to do this question? Because I know you've asked a lot of questions like this. Do you want to give it a go? Okay, you can't see actually. We're just doing, yeah, see?
Okay, well, we're just looking where the g of x graph is greater than the where the y values is greater. So
So you're looking for where the y value is greater, right, guys?
yeah.
Because it's g of x. G of x is not x, it's the y value. Okay, half x minus 3. Okay, so here's a better drawing of the graphs, just to make it easier for you.
When x is 0, it's greater than the other graph. G of x is greater than the inverse.
But they're asking for which values of x is the red graph greater than the blue graph. So what would you say, Naima? Where is it greater?
Next is
Wouldn't it be greater then from the point of intersection?
Yeah, so do you see, guys, see this point here? That's where they're equal. So when x is greater than this point, do you guys agree that the red graph is bigger than the blue graph? Naima, do you see it?
Yes.
And then when x is less, then the red graph is smaller. So what must you do to answer this question?
Find the point of intersection. You equate the two.
You can equate the two graphs, yeah, and you would get an answer of, I'm assuming, -6, just from looking at this graph, and -6. So therefore your answer will be, well, x must be greater than or equal to -6. Because they're saying greater than or equal to. Do you guys see that? Greater than or equal to.
Yeah.
And here they're equal, and here they're greater. Okay. Happy?
Yeah.
Everybody happy?
Yeah. Yep.
Any other questions? Because this was the last question. Is there anything else that you guys want to ask with regards to this question? Or happy?
Shukran.
Okay, now akhlaq. Now whenever akhlaq sends a question, I always get a bit worried now, because if he can't answer it, then that means I have to think now. No, that's not just. Guys can laugh, you can unmute your mics, it's if you, or you just dead. Must I unmute all your mics, because it's like it's, I don't want to talk to one person.
Too much noise in my house.
Too much noise. Okay.
I'm working outside by me, so I don't know. Can you hear it on the mic?
I can't actually hear it though. No.
Oh, okay. Because we're in front of my house now, so I thought it would be a bother with the mic.
Okay. How was your Eid, Rivka? I know last week I don't think were you here last week?
No, it's
No,
my
you-
camera.
Oh, okay. Okay. So okay, yeah. So Akhlaq, I want you to take me through, what did you think when you saw this question?
My mic's not working.
What do you mean it's not working?
It's working.
You just...
No, I'm joking. I don't know where to start here, to be honest.
Okay. This is not, I mean, these questions are not easy. 3D Trig is not an easy section. But I'm going to teach you an approach. I mean, I do go through the approach in the concept video. There's a concept on 3D Trig. I think it's on, is it here? It should be here. 3D Trig, functions, trigonometry. Let's check the grade 12. Solving problems in 3D, okay? How to approach problems in 3D and examples. So if you guys go through that, that will help you with an approach. But for this one, it's just kind of intuition. So, okay, it says there in the sketch alongside, PQ is a vertical line. Now that's really important. So Akhlaq, I can see you pointed that out because you've got a vertical horizontal line. So what does that mean?
90-degree angle.
Got a 90-degree angle, right? Okay, so you got a 90-degree angle. That's important. Now, when I see 90-degree triangles, there's certain things that pop into my head. For example, I think of trig ratios. Okay, so these are the things that pop up. Okay, RS equals √3. Okay, they tell you that. PRQ equals QPS. Where's PRQ? Okay, so you guys can see everything they've said in the question they've put here, right? But sometimes they don't always put it there. So you just have to make sure that you've read the question, okay? So, Akhlaq, this is what I do. I look at what they want. Okay, like they want cos theta. Do you see that? They want cos. Akhlaq?
Yeah, sorry. Actually, this one's not that bad. I think it's the other one that was harder.
Okay. But still the same approach to both questions. Cos, they want cos. I look at what they want. Okay. Where is cos theta over here? It's going to be this triangle. Do you see this one, this slanted one? Akhlaq, do you see that?
Yeah.
Okay. So cos theta, if you were to have cos theta, do you think using a trig ratio would help in this one?
No, I think
yes.
I think it probably.
Why not? Why not?
I think it probably because that's an angle from. Oh, it's not an 90-degree angle. It's not a right angle triangle.
Right. It's not a right angle triangle. So therefore, you're not thinking trig ratios because the trig ratios only work in 90-degree triangles. So which one is left? Which rule do you know of that you can use? The Cos rule. So do you guys see how it's almost like you're coming to these conclusions? Do I have one of the Cos rule? There we go. Okay. Now, if for those of you who don't remember Cos rule, there is a concept video. So it's a concept video on everything. So if you go back to the section mind map, if you look over here, you guys see sine rule, cos rule, area rule. So proving and using. So if you want to prove it, it's all there. Okay, if you want to revise. So a squared equals b squared plus c squared minus 2bc cos a. So there's your cos. You've got your cos. Okay. So if you were to have cos of theta, what would your a be? Akhlaq, what is your a going to be?
PR.
And how did you know that?
Because it's opposite the angle.
So guys, the a value, and this is in the concept video, the a value is always opposite the angle that you've chosen for cos. So if I say cos theta, here's cos theta, theta is opposite PR, so that's what's going to be over here. Okay. And then what's B and C going to be? Just the other sides of the triangle. So it's going to be PS, right? PS and RS, yeah. PS and RS, so we can just erase all this stuff here. PS and RS, PS times RS. And do we know RS?
Yes, root 3.
Right. Okay. So let's change RS. So what's RS squared going to be?
3.
3. Okay. So we're filling in stuff, right? We're filling in stuff. And RS is root 3. Great. Okay. Somebody's listening to some background music. Okay. So okay. So we're getting some. No, it's actually it's cos. Sorry, it's cos theta. PS. Okay, somebody's mic is a bit loud. Okay. Cos theta. Okay. 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 So what do you do now, Akhlaq? What did you do now? Akhlaq, what did you do?
You swap the PS with sine 30 degrees equals to x over p.
So
x over sine 30.
Okay, let's just back step. How did you know that? How did you know that?
Well, don't you have to get the PS in relation to x?
Yeah,
and same with
that's right. So do you guys see? Do you guys see that PS and PS and PR? That's not in here. Do you guys see that? It's not in here. So we're gonna have to replace them with something. But what's convenient is, can you see? Here's PS. Here's PR. You guys see that? Guys?
Yeah.
And here's your
Yes.
90-degree triangle. So what do you guys think we can do? Trig ratios, right?
Yeah.
Oh.
You see, so that's why when you see 90-degree triangles in trigonometry, always think trig ratios. If you don't see a 90-degree triangle, think cos rule, think sine rule. Okay, so you guys see the picture now. So, okay. So if you wanted to find PS, so you've got 30, right? So you've got X and you've got an adjacent and you've got a hypotenuse. So which ratio?
The
Cos.
cos ratio.
Never written that. Okay, your cos, yeah, equals X over PS. Happy?
Yeah.
And then PS is just going to equal X over cos 30. But cos 30 is root 3 over 2. So if you're dividing by cos 30, it becomes 2x over root 3. Okay, that's just, okay, it's going to be 2 over root 3. It's going to be the opposite, flipped over. What about RP? Who wants to do PR for me? Cheswin, you want to do PR? Okay. Hamza, you want to do PR? Oh, Cheswin, yeah, Cheswin, you want to do PR?
I'm shy.
Okay, Hamza, you want to do PR?
Yeah, sure. So you're gonna use sine 30 degrees is equal to x over PR.
Right, sine 30 equals opposite, which is x over PR. And therefore PR equals x over sine 30, right?
Which is 2.
Yeah, because when you're dividing by a half, that's the same as timesing by 2. So therefore PR is just x, 2x. Because if you think about it, if you wrote here 2x, what does that give you? What is x over 2x, guys? What's x over 2x?
A half.
And what's sine 30?
A half.
Okay, so you guys see this, okay? So okay. So PR squared, if PR is 2x, what is PR squared?
4x squared.
4x.
4x squared, great. And PS squared? It's a bit of a tough one. Not actually one. What's PS squared?
4x squared over 3.
Squared over 3.
Yeah, 4x squared over 3. 4x squared over 3. 4x squared over 3. And PS is 2x. So it's 2 times 2x, which is just 4x. Okay. So what can we do now?
Make cos theta the subject of the formula.
Yeah, because in the question, they want you to solve for cos theta, right? So how can we do that? So we can maybe take the other stuff over, right?
Yeah.
Or we can even take, if we take this over, then the negative falls away. Then we just take that over. Okay.
Mm-hmm.
So, yeah. So let's take over the cos. So it becomes 4x times root 3 cos theta equals 4x squared over 3 plus 3 minus 4x squared. Can we simplify this? What's the common denominator?
3.
Do you guys agree the common denominator is 3? Because this is 1, that's 1, so it's 3. Highest common factor. Guys?
Yes.
Okay, so you could, if you made it 3, then it's just going to be 3 over 9. Sorry, 9 over 3. Do you guys see that? And then minus 12x squared over 3. And then that gives you 16x squared. Sorry, minus 9 minus 8x squared over 3. Because this is 4 plus 9 minus 12x squared. Do you guys all see that?
Yeah.
Yeah.
Okay. And then we divide by, what's 4 times root 3? 4x times, 4 root 3, right? So what's 4 root 3 times, why does this not look right here? Did we make a mistake? Cos theta. Did we make a mistake? 2x squared. Because that should be 12x. This should not be here. 9 minus. Okay, let's just double check. So it's going to be 2x. That's 2x. Does anybody see a mistake that I maybe made?
I think we should divide by 4x on both sides.
Yeah, yes, but no, but if we do, then we get 12x, but then we're still left with the root 3. But you see what I'm saying? Because I'm just trying to see here. So if it's 2x.
Wait, why is the square root 3 anyways? Where did it come from again?
This square root 3.
No,
it's
the blue, the next line on the left hand side.
Yeah, this is just taken over.
Okay.
So let's just write down. So if this ever happens to you, and it will happen to you, it might happen to you, but it happens to all of us. Just write out again and see maybe if you made a calculation error. So it's going to be 2x squared equals 3, right? Which is RS plus PS squared, which is what? Let's just make sure that is 2 of x, 2 over 3. PS is, okay, so it's cos 30 equals root 3, cos 30 equals x over PS. Therefore, PS equals x over root cos 30, right? And cos 30 is root 3 over 2, which is 2 over root 3. Yeah, that is right. Okay, 2x over root 3, which is what we got. So therefore, it's going to be 3 plus 4x squared over 3 minus...
Oh, I see the mistake.
Okay. What was the mistake? I think
we got RS. Wait, yeah, RS was square root 3, but
yes,
our PS was wrong. Our PS is supposed to be 2x over square root 3, but we just put 4x there. It's supposed to cancel out, and then
I see. We didn't put that. Yeah. Wait. Yes.
Yeah, the square root 3s are supposed to
PS.
cancel out.
I put 4x for PR. Yes, I see. So that's going to be times 4x squared over. So 4x over root 3.
No, it was 2x over root 3.
2x over root 3, which is going to be times by 2, which is 4x, because it's minus 2. There's minus 2, right? 2x over root 3. Do you see that? It's minus 2ab cos theta. There's a 2 in front. Do you remember from the equation? Do you see there's a 2 in front? So it's going to be minus 2 times 2x over root 3 times root 3. So that cancels there, which means if we're left with root 3 cancelling there, which gives us cos theta equals 9 minus 8x squared over 12x. Okay. Do you guys get the picture? Do you guys see like how we've approached this question? Does anybody want me to like sort of say it again?
Yes, please.
Okay. So we started off by just writing down everything. And I started off by looking, what did they want? They wanted cos theta. And I asked myself, where can I get cos theta? Well, if I look at the triangle, you see there's theta, right? But theta is part of this triangle. It's not a right angle triangle. Do you guys see that? So when I see a non-right angle triangle, I'm immediately thinking to myself, okay, can't be a trig ratio. So maybe I have to use cos somewhere where it's not a 90-degree triangle. And the circumstance that I think of is the cosine rule. So do you guys see that? Because if you want to solve for cos theta, you have to have an equation with cos theta. You have to create an equation that has cos theta in it. And the only way you can create an equation with cos theta in it is if you use cosine rule. You can't use the trig ratios because this is not 90-degree triangle. Do you guys see that? It's not 90-degree triangle.
Yeah.
Okay. So now using cosine rule, you solve and you fill in everything that you have, but then you realize that you don't have PR and PS. But wait, PS is just part of a 90-degree triangle and PR is just part of a 90-degree triangle. Do you guys see that? PS is part of a 90-degree triangle, PR. And because of that, and I have an angle, I can then find PS and find PR. Even though it's in terms of X, because my question wants it in terms of X, I just substitute that in, I solve for cos theta and just don't make any stupid mistakes that I did. And you get cos theta equals that, which is what the question wanted you to solve for. Okay. Are there any questions? There's another question that I'm going to do on 3D trig. Is everybody happy with this one?
Yes.
Yeah.
Yeah.
Okay. All I
Wait,
want
we
you
didn't
guys-
get to the answer though.
Oh, sorry. Oh, no,
We
that
still
is
have
the answer.
12x. No, you need 12x in the denominator.
Yeah, so then it's, you divide out by, what do you mean?
Sorry, I didn't see that. My bad.
Oh, okay. Okay. So let's look at the next question. Okay, Akhlaq, where did you start? What did you think when you saw this question? Was it an issue of where to start again?
Not really, no. I think it's afterwards got a bit more tricky.
Okay. So let's read the question. In the sketch alongside, PO is a vertical line. Again, guys, you see vertical line. So what must you think of now? Vertical line, horizontal
90
plane.
90
degrees.
So there's your 90-degree triangle. Do you guys see that? So now they're basically gifting to you. They're trying to tell you something. What are they trying to tell me? Trig ratio. Okay. So do you guys see how they're very subtle here? They're very low-key, but they actually are telling you something. So, okay. PMO is alpha. NMO is alpha. MON is 150, ON is 2. So everything they've told you is there. Now they want you to solve for OP. OP. Now I must ask myself, where's OP? Where's OP? It's here, right? So what are you guys thinking for OP?
So find OM by using the other triangle.
Well, find an expression for OP first. So which triangle is OP in?
OPM.
And what do you know about that triangle?
You can write OP in terms of tan alpha.
It's a 90-degree triangle, guys. So because it's 90-degree, you can use trig ratios. So you want OP, right? But are you going to use PM or OM as your other side?
OM.
Why OM? And not PM?
It's OM because it's the common side between the two triangles.
Yes, you see, so what my maths teacher taught me in trig was that she told me that trig 3D is about working from the known to the common to the unknown. Or you could go from the uncommon to from the unknown to the common to the known. So we're doing it in reverse, but you could do either way. But I usually start with what they're solving for. So they're solving for unknown. Okay, so we're going from unknown, right, to common to known. Do you guys see that? Unknown, common, known. Do you guys see that?
Yeah.
Okay.
Yep.
So that's why we're going to use OM, because OM is common. So OP and OM, those are opposite and adjacent. So which ratio? Opposite and adjacent.
Sine.
Opposite adjacent.
10.
10. Okay. Okay. Just have to revise, or just make sure that okay, OP over OM, right? So now we solve for OP because they want OP, right? So it's going to be OM times tan of alpha. You guys happy?
Yep.
Yeah.
Okay. But now they want all this nonsense here. So how are we going to get that? Okay. So we have to find an expression for OM. Do you guys agree? We have to convert OM into something.
Could we use the sine rule for triangle OM?
Guys, I'm just going to restart the meeting because there's an issue with the that same thing that always happens, but I'll just quickly restart the meeting. Just join again.
Sine rule for triangle OM.